What's going on, everybody? Welcome back to my YouTube channel. Let's solve this math question, which says find the values of x for which x squared plus x squared all over x plus 1 all squared is equal to 3. Well, our first step will be for us to combine the fraction on the left-hand side. Now, to combine the fraction, I'll take the LCM. So the LCM is x plus 1 all squared. So I'll take this LCM, which is x plus 1 all squared. Then to make this a fraction, I can just put all over 1 here. So let's go. X plus 1 all squared divided by 1. I have x plus 1 all squared times x squared is x squared times x plus 1 all squared. Very good. Plus x plus 1 all squared divided by x plus 1 all squared. I have 1. So 1 times x squared is s squared. And this is equal to 3. Now our next step will be for us to expand what we have here. So this becomes x squared times, expanding, we're going to have x squared, and then 2 times x times 1 is 2x, so plus 2x, and then plus 1 squared is 1. Very good. Plus x squared all over the denominator, which is x plus 1 all squared. This is equal to 3. Very good. Now our next step will be for us to open up this bracket by using x squared to multiply. So x squared times x squared, I have x to the 4th plus x squared times 2x is 2x cubed, and then plus x squared times 1 is x squared, and then plus x squared all over the denominator, which is x plus 1 all squared, and this is equal to 3. Very good. Now simplifying what I have here, this gives x to the 4th plus 2x cubed, and then x squared plus x squared gives 2x squared all over the denominator, which is x plus 1 all squared, and this is equal to 3. Now our next step will be for us to factorize what we have here. So this is x to the 4th plus, now notice that 2x squared is common, so we can factor out 2x squared, open bracket. Now 2x cubed divided by 2x squared, I have x plus 2x squared divided by 2x squared, I have 1. Very good. All over the denominator, which is x plus 1 all squared, and this is equal to 3. Now our next step will be for us to separate the fraction. Now this we have x to the 4th all over the denominator, which is x plus 1 all squared, plus this is 2x squared times x plus 1 all over the denominator, which is x plus 1 all squared, and this is equal to 3. Well, this expression from indices can be written as x squared raised to the power of 2, because from indices 2 times 2 gives back 4 all over the denominator x plus 1 all squared, plus, now notice that x plus 1 can cancel out one of the x plus 1 from here, leaving behind just x plus 1 as the denominator, so that we have 2x squared all over x plus 1. And this is equal to 3. Very good. Now, our next step will be for us to apply the law of indices, which says when I have, for example, a to the n all over b to the n, as long as they have the same power or a common power n, this can be written as a over b all raised to that common power n. So we're going to be applying this to what we have here. So this becomes x squared all over x plus 1. Okay, let me just remove these brackets. I'm just going to be writing x plus 1. Now notice that the common power is 2, so I'm going to be grouping this with the common power of 2. Plus, now this is 2, this is 2, so I'm going to be writing 2 times x squared all over x plus 1. And this is equal to 3. Now notice that we have a similar expression, x squared all over x plus 1. We also have it here, x squared all over x plus 1. So we're going to be introducing a substitution by saying let this expression, which is x squared all over x plus 1, be equal to y. So that means this can be written as y squared plus, this is 2y, so 2y equal to 3. Very good. Now let's move 3 to the left-hand side so that we have y squared plus 2y. And as 3 crosses to the left, it becomes minus 3. And this is equal to 0. So we have a quadratic equation. Well, the good thing about this quadratic equation is that it is factorizable. So I'm going to be opening a bracket. Very good. And since I have y squared, that means y times y will provide out y squared. And then plus, and I'll bring out two factors. We have a and we have b. Very good. So what is a and b that will make this equation to be true? All right. Well, I'm going to be attaching a condition to a and b, which is the multiplication or the product of a and b must be equal to -3. And then the addition of a and b must be equal to 2. All right. So what comes to my mind is 3 times -1. So 3 times -1 gives -3. And then 3 plus -1 gives 2. Very good. So we can just say let a be 3 and b be -1. So let's plug in these expressions here. So we have y plus a is 3 times y plus b is -1, so we just put -1 there. Very good. And this is equal to 0. So we have two cases. So one of the case is y plus 3 is equal to 0, or the other case is y minus 1 is equal to 0. So for the first case, The value of y can be gotten by subtracting 3 from both sides. And when we do that, what do we have? We have y. 3 can cancel out negative 3. And then 0 minus 3 is minus 3. So this is equal to minus 3. So we've got the value of y to be negative 3 here. And then for the second case, we're going to be adding 1 to both sides of the equation. So I'll add 1 here. I'll also add 1 here. All right. So this becomes y. And then negative 1 plus 1 will cancel out. And this is equal to 0 plus 1 is 1. So these are the two cases we have. And we're going to be plugging these cases to what we have here in order for us to get the values of x. So let's go ahead and do that, starting with negative 3. So remember our substitution where we said x squared all over x plus 1 is equal to y. So we're going to start with the first case when y is equal to negative 3. So this becomes x squared all over x plus 1 equal to value of y, negative 3. Now our next step will be for us to clear the fraction, and we do that by multiplying both sides by x plus 1. So on the left we have x squared all over x plus 1. So I'll multiply this by x plus 1 equal to, this is negative 3 on the right. I'm going to be multiplying it by x plus 1. Very good. Now notice that x plus 1 cancels out x plus 1, thereby eliminating the fraction. And we have x squared to be equal to negative 3 times x plus 1. Now let's open up this bracket. We have x squared to be equal to negative 3 times x is negative 3x. And then negative 3 times 1 is negative 3. So we have a quadratic expression again. And we're going to be moving what we have on the left, on the right, to the left-hand side. So when negative 3x crosses to the left, it becomes positive 3x. So we have x squared. This becomes plus 3x. And as negative 3 crosses to the left, it becomes plus 3. Very good. And this is equal to 0. So this is a quadratic equation that cannot be factorized. So we're going to be using the quadratic formula to solve this. Here, a is the coefficient of x squared, and that's 1. B is the coefficient of x, and that's 3. And c is a constant term, 3. And the quadratic formula we're going to be making use of, since we're looking for x, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute into this quadratic formula. So x now becomes negative b. So negative b is 3 plus or minus the square root of b squared, that's 3 squared minus 4 times a is 1, times c is 3. Very good. All over 2 times a, which is 2 times 1. Very good. So this simplifies into x equal to negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 1 times 3 is 12 all over 2 times 1, that's 2. So making x to be equal to negative 3 plus or minus the square root of 9 minus 12 is negative 3 all over 2. And this simplifies into x equal to negative 3 plus or minus. Now this becomes the square root of 3i all over 2. So there are two values of x here. So one of them is negative 3. We'll go with a plus the square root of 3i all over 2. And then the second value is negative 3. This time, go with the negative minus the square root of 3i all over 2. So these are two complex solutions for x. Now let's move on to when y is equal to 1. So we are substituting here x squared all over x plus 1 equal to y. So let's put 1 here in place of y. So this is x squared all over x plus 1 equal to 1. Now our next step will be for us to clear the fraction by multiplying both sides of the equation by x plus 1. So for the left hand side, we have x squared all over x plus 1. We multiply by x plus 1. This is equal to 1. We multiply by x plus 1. Very good. Now notice that x plus 1 will cancel out, clearing out the fraction, leaving behind x squared to be equal to 1 times x plus 1 is x plus 1. Now let's move everything on the right hand side to the left hand side. So we have x squared. As x crosses to the left, it becomes minus x. As 1 crosses to the left, it becomes minus 1. And this is equal to 0. And looking at this quadratic equation, it is not factorizable. So we're going to be using the quadratic formula. Our a here is the coefficient of x squared, and that's 1. Our b is the coefficient of x, and that's negative 1. And our c is a constant term, which is also negative 1. So since we're looking for x using the quadratic formula is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute here. So we have x to be equal to negative b. So negative b is negative 1. So I'm going to be putting this inside a parenthesis, negative 1 plus or minus the square root of b squared, b negative 1. So negative 1 squared minus 4 times a is 1 times c is negative 1 all over 2a, which is 2 times 1. Very good. So this results to negative times negative makes positive. So this is 1, positive 1, plus or minus the square root of negative 1 squared is 1. And negative 4 times 1 times negative 1 gives positive 4 all over 2 times 1 is 2. So this becomes 1 plus or minus the square root of 1 plus 4, 5 all over 2. So there are actually two values of x here, which are x And this is going to be the third solution, equal to 1, go with the positive, plus the square root of 5 all over 2. And now the fourth solution for x is 1. This time, go with the negative root 5 all over 2. So we've got 2 real solutions and 2 complex solutions, making it a total of 4 solutions. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.